So example 2 is a special kind of question. I even give it a name. I call these questions multi-revolution questions. It's similar to what we've done before in that we're solving for an angle, but all of these questions have a horizontal stretch or compression built into them. So for example, it says solve sine 3x equals 0 over the domain 0 to 2 pi. Okay? So what we're going to do is we're going to write out some of the steps off to the side first for a multi-revolution question, and then look at how this particular one works. So in a multi-revolution question, the first thing that we're going to do is and I'm going to put 3x in apostrophe or quotation marks because our question has a 3x. If our question has a 2x, you would find the domain for 2x. If our question had a half x, you'd find the domain for a half x. So we're going to find the domain for 3x. So in our question over here, the original domain is between 0 and 2 pi. If 1x is between 0 and 2 pi, where would 3x's be between? 3x's would be between 0 and 6 pi. Does that make sense? If I got you to pick a number between 0 and 10. Okay? And then I said multiply it by 3. Does it make sense that everybody's number is now between 0 and 30? Because if you started between 0 and 10 and then tripled it, it would now be between 0 and 30. Well, here's the same thing. If we start between 0 and 2 pi for x, then 3x's would be between 0 and 6 pi. And this is part of the reason why I call it a multi-revolution question, because if you're solving for 6 pi, that's like 3 times around your unit circle. Number 2. Solve for 3x. And again, that's in quotation marks because that could change depending on your question. So in our question, we say, so step 2, 3x equals. Well, when is sine equal to 0? Is your y-coordinate ever 0 on your pi plate? Yes. Where? At 0. At 2 pi. It's also at pi before I get there, right? 0, pi, 2 pi. That's the first time around. Oh, okay. We're gonna do a slight change in a second, but we'll keep going. That's the first time around, but what is 3x in between? It's between 0 and 6 pi. So we need to go a second time around. Can you see it would be coterminal? You'd hit 3 pi and then 4 pi. Then the third time around, you would hit 5 pi and 6 pi. And I just noticed some little mistake that we made. I didn't read the question carefully enough. I am going to take out my eraser. Can you notice, well, first of all here, what's the difference between what they wrote and what I wrote? Yeah, this sign has to go away, which would make, when I triple it, this go away, which means I would have got an E8 error for writing something outside of the domain if I wrote 6 pi. Because 6 pi is supposedly not included. Okay. So step 1, find the domain for 3x. Step 2, solve for 3x, just like you're solving regular, right? When is sine equal to 0? But you now had to go 3 times around. because the domain for 3x was between 0 and 6 pi. Step 3, now we just have to solve for x. If 3x is equal to each one of those, how would you solve for 1x? Divide by 3, right? What happens if you do 0 divided by 3? You get 0. What happens if you do pi divided by 3? Pi over 3. 2 pi over 3. 3 pi over 3. I'm going to just reduce that to pi. Is that okay? 4 pi over 3 and 5 pi over 3. So for a multi-revolution question, that's when you have a horizontal stretch or compression inside of your function. We have to think about how that affects our domain, right? This is a horizontal compression. So does it make sense that you would take 6 pi and compress it to 2 pi, and you'd have a whole bunch of periods, 3 periods between 0 and 2 pi now? And so it makes sense that you would get more solutions because those solutions got squished between 0 and 2 pi. The way that we do it is we rethink of our domain now from 0 to 6 pi, find all the solutions, and then divide by 3. All of our final answers are between 0 and 2 pi. You could do the same thing with range, but that would be whenever we have things that are affecting our range, we can move those over to the other side of the equation. So it doesn't actually affect it. It's only if there's a horizontal stretch or compression that this has an effect. Now part B to this question. Part B says, state the general solution. For part B, the general solution, if we look at our notes, what did we write for the general solution? How do you find a general solution? You first find your answers between 0 and 2 pi. We've done that already. Then you take all of your answers and add 2k pi. So if you want to keep things simple, we can just write x equals, rewrite all of them, 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. Add 2k pi to each of them. Where k is an integer. This is a right answer. It is not the most elegant. I can show you a more elegant solution if you'd like, but this is correct. You're right, some of them could be combined. Like 0 and pi, if you just did 0 plus k pi, that would hit both of those, and you could combine those. And there might be some other ones that you could combine as well. Yeah, you have to write plus 2k pi next to all of them. Well, these ones are all, here you could just use an equal sign because they're all exact values. Yeah. Question?
Didn't you just do like a big like bracket thing and then just do 1 plus 2k so like to all
It doesn't take you that long. Okay? If you think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 18 letters. When you write your full name out, what's yours? Yours is like 11 letters. This is like only 7 letters more than your name. Doesn't take you that long to write out your name. Oh, and yours is even longer. Yours is 16. First and last. Oh, if you add your middle name, man, that'd probably take a couple days to write out. Yes. K pi over 3. Would it work? Oh, this is a 3. So he's saying I could combine these all because the pattern would be K pi over 3. Yes, that would work to make it shorter. So let's do another example. And in the second example, I'll show you a shortcut for it, or a different way to do the general solution. So let's call just another multi-revolution question. Maybe have, if you want to turn the page, you can write on the next page. We're going to skip question number 3. So you can write it on the next page if you want. Okay. Cos 2 theta equals So we recognize it as a multi-revolution question because of that horizontal compression. If we're not going to do example 3.
We're not doing example 3?
Yeah, we will.
Like ever?
I'm just kidding. No, we're not doing example 3.
So I can take up that space with this one.
What's wrong with example 3?
Okay, to start off, we will write our new domain for 2 theta. So if 1 theta is between 0 and 2 pi, 2 thetas is between 0 and 4 pi. Then we solve for 2 theta. Is cos ever root 3 over 2? What family?
Yes.
The 2 is in the function, which means there's going to be a horizontal compression of 1/2. Okay? Which means that you will have 2 periods squished into our normal. Okay? But what we're doing then is originally if we solve between 0 and 4 pi without that, and then do the half when we divide by 2, we'll get all 4 of those answers between 0 and 2 pi. It is not pi over 3. It's pi over 6 family. What quadrants will you look in? 2 and 3. So in quadrant 2, you would have 5 pi over 6. In quadrant 3, you would have 7 pi over 6. This is only once around the circle. What is the quickest way to find the second time around the circle? Add 2 pi. Now, if I add 2 pi to this one, can you see that it would be helpful to change it to the same denominator because you're adding fractions? 2 pi is 12 pi over 6. So if I add 12 pi over 6 to 5 pi over 6, I'm going to get 17 pi over 6. And same if I add 12 pi over 6 to 7 pi over 6, I'm going to get 19 pi over 6. So I got a common denominator for adding. And then to figure out for theta, we have to divide by 2. So you were asking when does that 1/2 compression come in? It comes in the question right here. These were the answers between 0 and 4 pi if there wasn't a compression. And then when you divide by 2, hey, does everybody know that dividing by 2 is the same as multiplying by 1/2? So then your denominator gets multiplied by 2. 7 pi over 12, 17 pi over 12, and 19 pi over 12. Now we're going to add the general solution. And I'm going to show you the general solution in two different ways. So if you solve between 0 and 2 pi first, like we did, then the easiest way to write the general solution is to take these four answers, take our four answers, 5 pi over 12, 7 pi over 12, 17 pi over 12, and 19 pi over 12, and add 2k pi to each of them. So if you've already solved between 0 and 2 pi, this makes the most sense. Okay? Notice when we had a 2 theta, there was 4 solutions. If we had 3 times around, you see that it would be 6 solutions? Does that make sense? From 0 to 2 pi. And if it was like a 4 theta, it would be like 8 solutions. Because usually you hit 2 solutions once around a circle. So depending on what the compression is, you could get a lot of answers. Like if this little thing didn't go down far enough? No. They just sort of go, oh, that's okay. Okay. So there is, if your question started this way, so we're going to do the same question, okay? But it didn't say between 0 and 2 pi. They just said find the general solution for cos 2 theta equals negative root 3 over 2. It's the same question as above, but it didn't first ask us to solve between 0 and 2 pi. If this is how the question was worded, you could do exactly what we did here. This would be right. You could solve between 0 and 2 pi first, and then write the general solution by taking all 4 of those answers. Okay? That's method 1. Method 2 for finding the general solution for a multi-revolution. So if we want to write this down, method 2 for general solution of multi-revolution. Whew. There's some abbreviations. 1, find the general solution for, and I'll put it in quotation marks, 2 theta first. And then write the general solution for theta. So what does it mean to find the general solution for 2 theta first? Well, the general solution would go 2 theta equals and then the squiggle brackets. And then, here I'll move it up so we can see the question. When is cos negative root 3 over 2? 5 pi over 6 and 7 pi over 6. 5 pi over 6 and 7 pi over 6. Plus 2k pi plus 2k pi, where k is an integer. That would be the general solution for 2 theta. You find your answers between 0 and 2 pi, which we did. Don't have to go between 0 and 4 pi, and add 2k pi. Then, if I have this as an answer, how would I get theta by itself? I would need to divide by 2. So 5 pi over 6 becomes 5 pi over 12. 2k pi, when you divide by 2, just becomes plus k pi. Divide everything by 2. And 7 pi over 12, divide by 2 plus k pi. K is still an integer. This would be accepted as well. The nice thing about this method is it's more elegant, right? So it has less answers. So this method in particular would be nice if you had like an 8 theta and you had to do the general solution. You want to see what that looks like? Want one more example? You don't have to write this down.
Well, you'd have 16 answers.
Yeah, if you went the regular way, you'd have 16 answers. You'd have to write all 16 plus 2k pi 16 times. Whew. So solve for theta. Sine 8 theta is root 2 over 2. So if I did the general solution for 8 theta, when is sine root 2 over 2? Pi over 4 and 3 pi over 4 plus 2k pi plus 2k pi. And then what would theta be? I could reduce that if I wanted to. No, because if you used method 1, it would just be so long and tedious. And sometimes when you have options for methods, some students just remember one method. And if they choose the longer one, that's annoying. Okay?
Is it annoying for the student or annoying for the marker?
Well, the marker doesn't matter. It's not that much. Now, so what this shows us is with how we originally, like the very first question that we solved, it asked us to find between 0 and 2 pi first. So then it made a lot of sense once we found our answers between 0 to 2 pi just to add 2k pi to all of them because we already had the answers between 0 and 2 pi. We didn't have to use a different technique because we were already mostly done method 1. Okay? In the second example, I also said solve between 0 and 2 pi first. We got our 4 answers, so the general solution, it made sense to do this. But if you had just asked the general solution to begin with, you could do this second method. And in this example, the second method is a lot faster than the first method, because you would have got in the first method between 0 and 2 pi, you'd have to go 8 times around the circle. That would give you 16 answers. Just writing all those down just takes a long time. So then this method would be better. All right, questions for practice?
Like, say you had 16 answers, you just write them horizontally with commas and then 2k pi at the end.
Supposed to write plus 2k pi with each one.